Today, we're checking into a hotel you've probably never heard of, but it's one that's absolutely critical to the life of every single modern city.
I mean, just think about that for a second. Every single flush, every shower, every drain in a massive city, all of it creates this huge volume of wastewater that has to be cleaned day in and day out. The sheer scale of that job is just staggering. So how in the world do we even begin to tackle that?
Yep, you heard that right. The answer isn't just a bunch of chemicals or some giant machine, it's biological. We've figured out how to build the perfect home, this perfect environment, for helpful bacteria to do all the dirty work for us. And honestly, they often do it using way less energy and fewer chemicals than other methods. So today, let's take a tour of this microbe hotel.
All right, let's get started. Grab your room key, because we're about to see how this incredible hotel for microbes actually gets the job done.
Okay, so the official fancy name for our hotel is a Rotating Biological Contactor, or RBC for short. It's what engineers call a fixed film process. Now, all that really means is that our microscopic guests, the biomass, they aren't just floating around freely. Nope, they live attached to a surface, kind of like residents in a massive high-rise apartment building.
And when I say massive, I mean it. A single one of these setups can provide 100,000 square feet of surface area. To put that in perspective, that's almost 2 acres. That's a huge amount of real estate, providing plenty of rooms for our whole microbial community to move in.
So how does the hotel deliver room service? Well, it's all about this constant, slow rotation. At any given moment, 40% of the disk's surface is submerged down in the wastewater. That's the hotel's 24/7 all-you-can-eat buffet, where the microbes chow down on pollutants. The other 60%, that's exposed to the air, which, as we're about to see, is just as important.
This whole design creates a really brilliant and simple 4-step routine for our guests. First, they eat. As the discs dip down into the wastewater, the biomass grabs onto all the pollutants, what engineers call soluble BOD, which is basically the organic food in the water. Step 2, they breathe. As the disc rotates up into the open air, they get all the oxygen they need to live. Third, they grow. You know, with all that good food and fresh air, the slime layer they live in gets thicker and thicker. And finally, when it gets a bit too thick, it's time to depart. The excess biomass just sloughs off and gets carried away to a clarifier to settle out. The guests have officially checked out, leaving a fresh, clean room for the next generation to move in.
Of course, any hotel this complex, with billions of tiny guests, needs a really good manager. So now let's look at how the human operators keep everyone happy and working efficiently.
You know, one of the most elegant things about this system is that you don't need a bunch of complicated sensors to know how it's doing. You just need your eyes. The hotel manager can tell exactly how healthy the system is just by looking at the color of the biomass. If it's a nice, light brown, perfect. The guests are happy and healthy. If it starts to look thick and shaggy, they're probably being overfed, there's an organic overload. And if it turns white or gray, the guests are getting sick. That usually means low oxygen, which lets some nasty, undesirable bacteria take over. The manager also has to choose the hotel's engine. There are 2 main ways to get these big discs to turn. An air drive system is pretty clever. It uses rising air bubbles from below to physically push and rotate the shaft. The cool part is that it also adds extra oxygen to the water at the same time. The other option is a classic mechanical drive, a traditional motor and chain. It gives you a more consistent speed and usually uses a bit less power. It's a classic trade-off between different kinds of efficiency.
Now, most of the guests at this hotel are there for the main buffet, just removing general organic waste. But some of these microbe hotels have a special, exclusive section for their most discerning clients. We'll call it the VIP nitrification wing. This part of the hotel, this special wing, is dedicated to removing one very specific and troublesome pollutant, ammonia. And to do this, the hotel needs to attract and take care of a very special kind of guest, nitrifying bacteria. And let me tell you, these VIP guests are extremely demanding. Their list of requirements is like a rock star's contract writer. The oxygen level has to be in this perfect Goldilocks zone. Not too much, not too little, the temperature can't get too cold or they just stop working, the pH has to be just right, and, this is the big one, they are incredibly picky eaters. They will not do their job if there's too much of that regular organic food that the other bacteria love. It is a really delicate balancing act to keep these VIPs happy.
So what happens when things go wrong? I mean, even the best-run hotels get complaints now and then, and the microbe hotel is no different.
Right. So when the system's performance starts to drop,
It's basically like getting a one-star review online. The manager has to jump into action, figure out what the complaint is, and find a way to fix it fast.
So here's a look at the manager's troubleshooting guide. If the complaint is, hey, service is slow, meaning efficiency is down, it's probably an organic overload. The fix? Give the microbes more dining space by opening up the facility. If the complaint is, ugh, the food is bad, and you see that white biomass, the incoming water is probably septic, meaning it has no oxygen. The solution there is to pump some air into it beforehand. And if the complaint is, everyone is leaving, like a mass checkout, that's probably a toxic shock from an industrial polluter upstream. The manager's most urgent job is to find and eliminate that toxic source.
And really, this all highlights the most important rule of running a micro-hotel. For all its clever design, it's only as good as the water it gets in the first place. All the treatment steps that come before it have to be working perfectly. I mean, think about it. You can't run a 5-star restaurant if your food deliveries are already spoiled when they arrive at the back door.
What this shows us is just a brilliant example of harnessing a living biological system to solve a massive engineering problem. It's elegant, it's efficient, and it's all powered by nature itself. Which, it kind of leaves you with a final thought. If we can build an entire hotel for microbes just to clean our water, what other amazing natural processes are out there just waiting for us to understand them and put them to work?